The invasion's greatest machine was almost paralyzed by water. Not German mines, artillery, or armored counterattacks, a 3-day storm accomplished what the coastal defenses had failed to do. It tore an American artificial harbor apart before that harbor was fully finished. When the wind eased, more than 300 landing craft littered the Omaha shoreline. Concrete caissons had cracked, shifted, or disappeared beneath the turbulent water. Floating roads lay twisted among wreckage that could no longer be repaired economically. The German defensive system had treated major ports as the indispensable gates of an invasion. Destroy those gates and an army landing without them should eventually starve. Now the Allies had lost the mechanical port created to escape precisely that trap, yet the supply machine did not collapse. Within weeks, American forces were receiving more cargo through Normandy than planners had expected with the harbor intact. How could a wrecked beach replace an engineered port? The answer begins with a distinction hidden by the word harbor. Mulberry A was never a single structure. It was a connected system of sunken ships, concrete breakwaters, floating piers, roadways, tugs, barges, trucks, and specialized crews. Each component solved a different part of the same problem. Large ships needed shelter. Landing vessels needed routes through changing tides. Cargo needed to cross the final stretch of water, reach firm ground, and leave the beach before congestion stopped everything. The harbor promised to make those movements predictable. But predictability created its own vulnerability. If waves broke the connections, the entire arrangement could lose capacity faster than individual pieces could be replaced. That weakness appeared during the night of June 18th. A strengthening northeast wind drove heavy seas directly against the Normandy coast. By the following afternoon, ferry operations had stopped. Ships searched for whatever shelter the unfinished breakwaters could provide. Unloading slowed, then nearly ceased across the exposed anchorage. The storm continued through June 19th, 20th, and 21st. Wave after wave struck machinery designed for demanding conditions. But not for this prolonged punishment. At Omaha, incomplete breakwaters allowed the sea to attack the harbor's internal structures. Floating pier sections rose, twisted, and hammered against their anchors. Landing craft dragged loose or were thrown onto the beach. Several concrete Phoenix caissons fractured or settled into unstable sand. By the morning of June 22nd, Mulberry A was judged beyond practical restoration. Its British counterpart at Arromanches had also suffered damage. However, its position offered better protection, and additional components salvaged from Omaha helped sustain it. The American harbor would not receive the same treatment. Repairing it meant consuming scarce equipment and labor while exposing new structures to the same coastline. The decision was severe but rational. Mulberry A was abandoned. That should have produced a logistical catastrophe. Allied planning had depended upon a rapid buildup of soldiers, vehicles, ammunition, fuel, food, and engineering equipment. The forces ashore could not pause while another harbor was manufactured. Cherbourg had not yet become the functioning supply answer planners wanted. Its approaches remained contested, and German demolitions would leave its port facilities badly damaged. Every day without cargo strengthened the danger that German reinforcements could contain the beachhead, but the storm revealed something the original plan had obscured. The artificial harbor was only one pathway through the supply network. Around its wreckage remained thousands of sailors, engineers, beachmasters, truck drivers, repair crews, and landing specialists. They still possessed smaller craft, surviving breakwaters, open beaches, tidal schedules, and hard-earned unloading procedures. The harbor had failed. The network had not. Before the storm, these overlapping methods looked like supporting arrangements. After the storm, they became the main system. Cargo vessels could anchor offshore and transfer loads into landing craft. Amphibious DUKW trucks could swim from ships toward the beach, climb onto land, and continue toward inland dumps. Coasters could be deliberately grounded at high tide, then unloaded when the receding sea left them accessible. Rhino ferries carried vehicles and heavy cargo across the final gap. Trucks removed supplies before incoming loads transformed the shoreline into an immovable warehouse. None of these methods was elegant. Together they created redundancy, and redundancy was about to turn a shattered harbor into a misleading symbol. The wreckage suggested that the supply line had been severed. In reality, its most important routes were beginning to multiply. The first advantage came from something that looked almost absurd beside the ruined harbor. It was a truck that could swim. The Duke carried less than a coaster, barge, or landing ship. Its value came from eliminating transfers. Cargo could move from a ship offshore, cross the water, climb the beach, and continue directly toward a dump. Every avoided transfer saved time, labor, and another opportunity for congestion or damage. During the storm, the surviving DUKWs had escaped destruction by remaining parked ashore. When the sea became manageable again, those ordinary-looking amphibious trucks returned to the water. They did not replace Mulberry A by themselves. They connected ships, beaches, roads, and inland depots while larger unloading methods recovered. This distinction mattered. The Allies did not possess one miraculous machine immune to failure. They possessed different machines whose weaknesses did not always appear at the same moment. A floating roadway might fail in heavy seas. A DUKW carried less cargo but required no roadway. A landing ship could place enormous loads near shore but depended upon tides and suitable gradients. A grounded coaster surrendered mobility, yet became a temporary warehouse accessible from the beach. When one route narrowed, traffic could be redirected through another. Men made that flexibility work. Naval beach battalions controlled arriving craft and marked usable approaches. Army engineers cleared exits, repaired roads, and created places where vehicles could turn without trapping those behind them. Transportation units scheduled trucks and moved cargo away from the shoreline. Signal personnel carried reports between ships, beaches, dumps, and headquarters. Salvage crews entered wreckage fields to recover vessels, engines, cables, ramps, and pontoons. The essential mechanism was not merely unloading, it was circulation. A beach could receive thousands of tons and still fail if the material remained near the water. Incoming ammunition blocked incoming fuel. Stationary trucks blocked ambulances and repair vehicles. Damaged craft obstructed working landing lanes. A successful discharge system therefore had to clear cargo almost as quickly as ships delivered it. That required information. Beach officers reported capacity, congestion, surf conditions, and the condition of exits. Control organizations adjusted the sequence of incoming craft. Truck companies shifted loads toward ammunition, fuel, ration, and engineering dumps. Repair and salvage teams restored whichever component could return capacity fastest. The machine regenerated by constantly deciding where limited labor mattered most. The Germans faced a different problem. They could observe wreckage and recognize the absence of a functioning American Mulberry. What they could not easily measure was the distributed capacity spread across open beaches and minor facilities. There was no single replacement harbor to identify and destroy. The replacement was a pattern of repeated actions. A landing craft arrived, a ramp dropped, a truck moved, a salvage crew cleared the lane, another craft followed. Individually, each event appeared small. At scale, the repetitions moved an army. This was why the destruction of Mulberry produced less strategic damage than its appearance suggested. The port had concentrated equipment, but the broader system had dispersed knowledge. Crews already understood tides, beach gradients, cargo handling, vehicle movement, and emergency repair. They had trained for the invasion before seeing Normandy. They had also learned under fire after landing. The storm destroyed structures. It could not erase those procedures, nor did the Americans simply return to their original schedule. They revised priorities around what remained usable. The gooseberry shelter formed from deliberately sunken blockships had survived better than the exposed artificial harbor. Its protected water still helped smaller craft operate. Beach installations were reorganized. Damaged equipment was stripped for usable parts. Unloading resumed wherever local conditions permitted, instead of waiting for a complete central facility. This was an industrial principle applied to a coastline. Do not demand that every component survive. Ensure that the system can absorb its loss. The method carried costs. Open beach unloading remained vulnerable to weather. Small craft required more trips and more crews. Saltwater damaged machinery and supplies. Sand entered engines, bearings, weapons, and packaged cargo. Men worked long shifts among unstable wrecks, while unexploded ordnance and occasional air attacks remained threats. Nothing about the replacement system was effortless. Its strength came from accepting inefficiency without accepting paralysis. A damaged route could operate below ideal capacity and still contribute. Several imperfect routes could then produce more total movement than one sophisticated route awaiting repair. That principle would soon appear in the tonnage records. The harbor visible from the shoreline was dead. The invisible harbor had expanded across the entire beach. The numbers began overturning the apparent verdict of the storm. Allied planners had expected the Normandy beaches and ports to reach a combined American discharge capacity below 26,000 tons per day. That planned peak was supposed to arrive roughly 90 days after the landings. By then, permanent ports were expected to carry a growing share of the burden. Reality refused to follow that sequence. Cherbourg fell in late June, but capturing a port did not make it operational. German forces had demolished cranes, blocked entrances, wrecked rail facilities, and scattered mines through the approaches. The harbor required extensive clearance and reconstruction before it could handle cargo at useful scale. This created the precise interval Mulberry had been designed to cover. But the American Mulberry no longer existed. During the breakout in late July, nearly 90% of American supply support was still entering through the beaches. The system was strained. Discharge averaged roughly 20 to 25,000 tons per day, below estimated requirements of about 30,000. Shortages and delays remained real. Yet the armies were not immobilized inside the beachhead. The same temporary network that survived the storm continued feeding the forces as they broke through the German front. That was the first operational proof. The stronger proof arrived after the battlefield began moving away from Normandy. Distance should have made the beaches less useful. Every mile inland lengthened truck journeys, consumed fuel, increased wear, and delayed the return of empty vehicles. A crate unloaded efficiently at Omaha still had to reach the formations demanding its contents. The beach solved only the first section of a growing logistical problem. Even so, its discharge performance increased. By early September, American intake through the Normandy beaches and ports averaged more than 28,000 long tons per day. On some days, it exceeded 30,000. This was achieved despite the abandonment of Mulberry A. The actual flow had surpassed the maximum originally forecast for those facilities. The result did not prove that artificial harbors were unnecessary. Mulberry B continued serving British and Commonwealth forces at Arromanches. Its sheltered unloading capacity remained valuable long beyond the initial mission envisioned for it. Nor did the American result mean open beaches were universally superior to ports. The method depended upon local geography, overwhelming naval access, specialized craft, trained organizations, and favorable periods of weather. It consumed labor and transport that permanent facilities could use more efficiently. The lesson was narrower and more powerful. A temporary port was not the only way to create port capacity. Capacity could emerge from a network of beaches, small vessels, grounded ships, amphibious trucks, surviving shelters, repaired roads, and disciplined traffic control. The storm had destroyed a structure. It had not destroyed the functions distributed around it. German demolition policy at Cherbourg revealed the difference. A conventional port concentrated its essential functions in channels: quays, cranes, warehouses, railways, and road exits. Wrecking those components imposed a reconstruction problem with a clear physical center. The beaches offered fewer decisive targets. Destroy one landing craft and another could take its place. Crater one exit and engineers might open another. Damage a vehicle and repair crews could recover parts or restore it. Interrupt unloading during bad weather, and ships could wait offshore or redirect when conditions changed. The system bent repeatedly. It did not remain unbroken. Cargo accumulated in the wrong places. Ammunition categories became difficult to locate. Vehicle shortages delayed clearance. Storms and high surf still shut operations down. Units at the front sometimes received less than requested. But local failures no longer guaranteed a general collapse. This regenerative capacity changed the mathematics of attack. To stop a centralized harbor, an enemy could concentrate destruction on a few indispensable installations. To stop an entire beach network, disruption had to be repeated across many landing points, craft, roads, dumps, and work crews. German forces lacked the air and naval power to sustain that pressure over the Channel and the Normandy coast. Their weapons could still inflict losses. They could not reliably prevent replacement and rerouting. The decisive comparison was therefore not between one German facility and one Allied facility. It was between two rates. How quickly could damage remove capacity, and how quickly could the supply network create it again? For 3 days, the storm won that contest completely. Then the balance reversed. Every salvaged craft, cleared beach exit, repaired truck, and reorganized dump restored part of the flow. The individual gains were unimpressive. Their accumulation was not. By September, the abandoned harbor no longer defined American capacity. The beach organization surrounding its remains did. The Allies had not repaired Mulberry A, they had replaced the need for it with thousands of smaller movements. Success on the shoreline created a new danger inland. Cargo could now arrive faster than the transportation system could always move it forward. The beach network had solved the missing harbor problem. It had not abolished distance. After the breakout from Normandy, American formations advanced far beyond the supply areas built near the coast. Fuel, ammunition, food, replacement parts. And medical stores still entered through facilities hundreds of miles behind them. Every additional mile consumed truck capacity in both directions. Vehicles carried loads eastward, then returned empty to collect more. Engines wore down, tires failed, drivers lost sleep. Road congestion turned theoretical capacity into stationary columns. This revealed the deeper meaning of the Normandy recovery. A supply system was only as strong as its slowest transfer. Ships crossing the Atlantic represented abundance. Beaches converted that abundance into cargo on French soil. Truck routes had to convert it again into combat power at the front. If any stage stopped circulating, the apparent surplus behind it became useless. German resistance exploited this problem even without severing the beaches. Demolished bridges forced detours. Damaged railways denied the Allies the most efficient method of moving heavy loads inland. Ports were wrecked before withdrawal. Road junctions became choke points. Retreating forces could not halt the Allied system permanently, but they could increase the time and fuel required for every delivery. This was a countermeasure based on friction, make the enemy repair everything, force trucks onto longer routes. Turn rapid pursuit into a contest between advance and exhaustion. The Allies answered with the same logic that had preserved the beaches. They divided functions among specialized organizations and created alternatives before existing routes reached complete failure. Engineers repaired bridges and railways. Transportation units concentrated trucks on controlled supply corridors. Maintenance teams recovered disabled vehicles and returned them to service. Military police regulated intersections and enforced one-way traffic where congestion threatened movement. Depots moved forward as conditions allowed. Again, no single element produced the result. The mechanism depended upon coordination. Information about consumption moved backward from fighting units. Requests were compared with stocks, transport availability, and route conditions. Depots assembled loads. Truck companies carried them forward. Empty vehicles returned through separate channels whenever possible. Repair units kept the carrying fleet from shrinking faster than it could be replaced. The same mathematics governed landing craft at Omaha and trucks across France. Possession mattered less than availability. A vehicle undergoing repair carried nothing. A vehicle trapped in traffic carried nothing useful to the front. A vehicle sent toward the wrong dump could consume scarce fuel while reducing effective supply. The system needed machines, but it also needed schedules, road discipline, maintenance, and accurate reports. This was where industrial abundance became operational power. The United States could provide huge quantities of vehicles and replacement equipment. British, Canadian, and other Allied organizations contributed their own transport, engineering, port and beach expertise across the coalition's sectors, but abundance alone did not guarantee movement. It became decisive only when standardized equipment and repeatable procedures allowed thousands of ordinary crews to keep the network functioning. A truck could be repaired because parts, tools, and trained mechanics existed behind it. A DUKW could perform repeated ship-to-dump journeys because fuel, maintenance, traffic control, and unloading crews supported it. A landing beach could exceed expectations because its output was measured, adjusted, and cleared. The spectacular object was the floating harbor. The decisive habit was continuous correction. That habit also explains why the loss of Mulberry A did not produce an improvised panic lasting for months. Improvisation certainly occurred. Crews salvaged components, altered unloading points, and adapted daily to tides and weather, but they improvised inside an existing administrative framework. Responsibilities had been assigned. Beach groups had practiced cargo handling. Engineers understood road construction and salvage. Naval units controlled movements offshore. Transportation officers tracked the flow inland. The organization could absorb unexpected methods because its central purpose remained clear: keep material moving away from ships and toward the units consuming it. The German defense confronted not an invulnerable harbor, but a learning network. Damage supplied information. Congestion exposed a weak exit. A stranded vessel revealed a salvage requirement. A shortage at the front exposed a failure somewhere between the depot and the fighting unit. Each problem could be reported, isolated and assigned. Not every correction worked. Not every shortage disappeared. The advance eventually outran its supply system and slowed. Yet this limitation strengthens the central point. Allied logistics was not magical. It survived because failure was expected, measured, and answered before it became universal. Mulberry A had been built as protection against one catastrophic bottleneck. Its destruction revealed a stronger protection already surrounding it. There was no single bottleneck left to break. The strategic consequence appeared beyond the surf line. German forces could still contest villages, hedgerows, roads, and river crossings. They could delay the Allied advance and impose severe losses. What they could not do was make the destroyed American harbor equal a destroyed invasion. The beachhead continued, receiving the material needed to expand. Reinforcements crossed the channel. Vehicles replaced losses and carried formations inland. Ammunition sustained artillery and infantry operations. Fuel kept the growing transport system moving, even as demand repeatedly strained supply. The storm had purchased time for the German defense. It had not reversed the campaign. That outcome was not guaranteed when the waves began rising. Had the storm continued longer, struck earlier, or destroyed more sheltered anchorages and specialized craft, the consequences might have been much worse. Had German air and naval forces been able to attack the unloading areas continuously, recovery would have become far more difficult. Had engineers failed to clear exits, cargo might have buried the beaches beneath their own success. Redundancy reduced risk. It did not eliminate it. The system also carried a human cost easily hidden inside tonnage tables. Crews worked in cold water beside unstable structures and damaged vessels. Drivers and handlers moved heavy cargo for exhausting hours, often under pressure to clear each load before the next arrived. Salvage parties entered tangled wreckage where cables, broken metal, shifting hulls, mines, and surf remained dangerous. Repair personnel kept machines operating in sand and salt that attacked engines and moving parts. Their labor converted available equipment into usable capacity. Without them, the impressive inventory would have remained a collection of stranded objects. French civilians also lived inside this expanding logistical landscape. Road movements, military construction, bombardment, and the destruction accompanying the Normandy campaign disrupted towns, farms, and families. The infrastructure supporting liberation grew through a region already suffering occupation and combat. The supply achievement cannot be separated from that reality, nor should Mulberry A be remembered simply as a failed invention. Before the storm destroyed it, the harbor helped unload cargo during a critical stage of the buildup. Its surviving breakwaters continued, providing shelter after the floating piers were abandoned. Components and lessons from the American site supported operations elsewhere. Mulberry B at Arromanches remained active far beyond its planned temporary role. The two harbors met different fates, but both belonged to the same British-led engineering answer to the port problem. The American recovery did not disprove that answer. It demonstrated why the broader invasion plan contained overlapping ones. Artificial harbors added capacity. Blockships created sheltered water. Dukes connected ships directly with land routes. Landing craft exploited beaches and tides. Engineers opened exits. Truck units cleared cargo. Depots sorted it. Signal and control organizations decided where the next movement should go. The power existed in the connections. By early November, when operations on the beaches had nearly ended, Normandy ports still handled a major share of American discharge. The temporary system had remained useful long after planners expected its importance to decline. Permanent ports eventually became essential as Allied armies moved deeper into Europe. Antwerp, once its approaches were secured, offered the scale and proximity demanded by future operations. Open beaches could not support an unlimited advance across a continent. They had performed a more specific task. They kept the invasion alive until larger facilities and transportation networks could take over. That is why the ruins at Omaha can be misleading. They show concrete fractured by waves. They show landing craft thrown onto sand. They show floating roads reduced to disconnected sections. They appear to record the moment an enormous logistical plan failed. But the real plan was larger than the visible harbor. It included the ability to abandon a broken component without abandoning its function. When Mulberry A died, cargo shifted to smaller craft, amphibious trucks, grounded coasters, surviving shelters, and reorganized beaches. When those methods created congestion, engineers, transport officers, drivers, and labor crews pushed the bottleneck inland. When the armies advanced beyond Normandy, the same culture of routing, repair, and substitution followed them. The 3-day storm exposed every weakness in the artificial port. It also revealed the strength of the system behind it. Return to the shoreline after the wind has passed. More than 300 craft stand wrecked or stranded along the beach. The concrete harbor is finished, yet engines restart among the debris. A DUKW enters the water. A salvage crew clears another lane. A truck leaves carrying cargo that has already begun its journey inland. The object failed. The network regenerated. That was how a storm destroyed an Allied harbor without breaking the Normandy supply machine. If this story changed how you see wartime logistics, subscribe for the systems behind history's decisive battle.